All right, so here are the last two questions. We're going to do this with calculus, and then who's already done this question using the physics that they know? Yichi has. So then Yichi is going to do it with physics right after, okay? But first we'll do it with calculus, okay? The thing you need to know is the derivative of displacement is velocity, the derivative of velocity is acceleration, and you do need to know about gravity, that acceleration. So we need to know that acceleration is negative 9.8 meters per second squared. So if we know that, we can work backwards, integrate, and we're going to find our velocity. Our velocity is just, well, what's the integral of a constant? Add an x. I'm going to use a t because we're dealing with time here, because we got meters per second squared. Negative 9.8 t plus c, right? When you integrate, you have a plus c. Do we have enough information to find out what c is?
Yes, because we have 7 meters a second.
When does that happen?
Right
Right
at the beginning.
at the beginning when time is 0. So velocity is positive 7. And so now we have our velocity equation, negative 9.8 t plus 7. How long will it take the golf ball to hit the ground at the bottom of the cliff? Well, now we can look at our displacement formula. If we go back another step, S would equal negative 9.8 t squared over 2 plus 7t plus d.
So S is displacement.
S is displacement. You can use a little d if you would like as well. That's fine.
Like I have my one from the other course.
Yeah. But you don't have this one. See if this is the right one or if this is from the other course. Okay, what's d? What happens at time 0? What is?
Well, it hits the ground. Oh, no, time. Oh, it's being thrown.
Okay. At time 0, its displacement is? 0, right? Because it's starting right where it is. So d will be 0. So now we have a formula for our displacement, because d is going to be 0 at time 0 because it has no displacement. Now what we want, so now we've got plus 0. Okay. Guess we could also, depends on how you want to look at this, where you want to put the graph. Some people would say, well, maybe I call my displacement based on where ground level is. Some people would do that. And then I could say at t equals 0, the displacement is at 75. So you could think of it that way as well. What would you rather? Do you like the idea of d being 75? Because then that would be the height of it. Then your formula for displacement is based on the actual height, because we're starting here with our cliff 75 meters up. Makes more sense. Other than that, it's just a transformation. When it hits the ground, if you start 75 meters up, what's the height going to be when you hit the ground? It's going to be 0. If you started with the displacement at 0, what's the height? What's it going to be when it hits the ground? Negative 75. Either way, it'll get the same result. Because watch what happens. If I say now I want to figure out what time we'll give it when this is 0, if I move this over, that would be negative 75. How do we solve something like this? Probably quadratic formula. Should we graph it and find out when it hits the ground? Okay.
So plus 0 plus 75, there's not any real difference in the end?
It won't, because if you do the 0, then what we're going to find now is we're going to find out when this is 0, right? That's what we're going to find. Okay? If we did it the other way, you would say there's a 0 here, but I need to find out when it's minus 75. Well, how do I solve it? I move the 75 over to the other side, and I get the same equation. Can you give me one more decimal place?
1.
Are we dealing in seconds? Yes, because we had meters per second squared before.